So in this video, we're going to go through sample question 24 from the Society of Actuaries ExamP list of sample questions. The question reads, the number of claims per month is modeled by a random variable n with probability n equals little n equal to 1 over n plus 1 times n plus 2 for non-negative integers n. And we want to calculate the probability of at least one claim during a particular month, given that there have been at most 4 claims during that month. All right, so this is a super easy problem. I'm assuming you know certain notation, right? Like what that would mean, things like that. But this really doesn't require a lot. So the question is ultimately asking us this. So the probability of at least one claim during a particular month, so the probability that the number of claims is greater than or equal to 1, given that there have been at most 4 claims during that month, given that the number of claims you have is less than or equal to 4. And that's a conditional probability problem. So this should be equal to, in the numerator, the probability that your claim is greater than 1 and less than or equal to 4, right? So probability of being greater than or equal to 1 and less than or equal to 4 divided by the probability that the number of claims you have is less than 4. Now, let's write this out a bit more explicitly because we're given kind of a discrete distribution. So the probability that your claim is at least 1, but at most 4, is the same thing as the probability that the number of claims you have is 1, or 2, or 3, or 4. Well, the probability that your claims is at most 4, well, that should be the probability that the number of claims you have is either 0, or it could be 1, or 2, or 3, or 4. Okay, so let's figure out the individual probabilities of each of these scenarios. And that's just this equation here. I'll write that to the side. So the probability that n equals 0, it's equal to 1 over 0 plus 1 over 0 plus 2. Okay, and that is equal to 1 over 2. Now I'm not going to do this out for every single one. I'm assuming you at least know how to do that. When n equals 1, it's 2 times 3 is 6. That's equal to 1 over 6. The probability where n is equal to 2, that's equal to 3 times 4, 12, is 1 over 12. The probability that the number of claims you have is equal to 3. That's going to be 4 times 5, 20. That's equal to 1 over 20. And finally, the probability of the number of claims you have equaling exactly 4. Well, that is equal to 5 times 6, 30. That's 1 over 30. Okay, now these are my individual probabilities. So in my numerator, that's the probability of this happening, or this, or this, or this. So I just sum them up, and I'll just punch those into my calculator. 1 over 6 plus 1 over 12 plus 1 over 20 plus 1 over 30. And that's equal to 1 over 3. So here, my numerator is 1 over 3. Meanwhile, my denominator is, rather than just the sum of these, it's the sum of all of these and the probability that the number of claims is 0, right? because those are all the possibilities where your number of claims is less than or equal to 4. So adding that last bit on gets you a denominator here of 5/6. Okay, and computing that, just doing that division gets you a final answer of 2/5. Right, so just gonna write that to the side here of 2/5, which lines up with answer choice B. Okay, so overall, an extremely easy problem, right? And I don't, mean to sound any kind of like a jerk when I say this, but this should be a super easy, straightforward problem. There is not going to be a question on ExamP that's anywhere close to this kind of low level of difficulty. This is just mainly testing kind of one concept, knowing you know certain notation, right? So this should be a breeze. And if you struggle with it, sure, study up, but the topics to study really here are conditional probability and trying to use discrete probability. Hopefully that video helped you if you're having a bit of trouble. If you have any questions, throw it down in the comments. And if this video did help you, hit the like button, subscribe. That totally helps me. Other than that, good luck, guys.